Oh, good. We're getting more students now. Come on in, Kim. Oh, do you mind moving that a little bit to the right? If we can just get it back on the projector screen. Oh, too much. A little more left, 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 left. Well, there you go. Perfect. A little left. Just a little left. Yeah, perfect. It's fine. It'll do. It'll do. Thank you. Okay, let's open up this exam. What question number are we on now? Do you know the question number we're on?
We were at A5. No, A. Sorry. A8.
8. What version? Version 1. A8. A8 is what I should do now, huh?
Oh wait, I did enter A, but I don't know if we discussed.
Yeah, okay. Let's see.
We did discuss A4.
I think it's A5. I don't remember doing A5.
Yeah, I don't think so.
Yeah, let's have a look at A5. Okay. I'll give you a minute if you want to open it up on your phone so you can have it there too. Just let me know when you're ready. You saw the fire in France last night?
Yeah.
Yeah. I don't know how it started. Okay, you got it, Kim? Yep. Okay, let's have a look. The heating system of a car The heating system? Oh yeah, okay. The heating system of a car windscreen is made up of 10 elements in series, each of resistance 2, and the EMF is 12. What's the total resistance? Okay, so they're in series. So the total resistance would be 1 over 2. Oh, sorry. Hey. In series. So it's just going to be 2 plus 2 plus 2. There's 10 of them. So that would make 20 ohms in total. That's fine, isn't it? Yeah? Right, what's next now? What is the power? Okay. You have power equals IV, and you have the VIR triangle. Now we know the OR, and we know the V. We don't know the I, so I think we can write it as V squared over OR.
Why V squared?
I replace the I with V over OR.
Oh.
So, let's see. That'd be 4, no it would not. What's the 12? 144 over 400. Yeah? 70, is that 0.36 watts? It'd be great if someone could confirm that. Yeah? And then the last part...
The 20 is squared as well, the R.
Say again?
Is the R squared as well?
No, the OR... Oh, thank you. Why did I square the OR? That was terrible of me. Absolutely terrible. Thank you, Andek, for spotting that. So that's over 20. So that's 7.2?
Yeah.
Biscuits. I had 2 already this morning. I had 2 biscuits and porridge. What flavour have you got? Cocoa? Oh, they're the other ones. Yeah, how are those? Are they nice?
Yeah, it's like it tastes similar, but there's something jam inside.
The jam inside.
Yeah.
Fancy. Okay. No, I'm good. I had loads of biscuits this morning. Thank you, though. Okay. The next part is they ask you to do everything again if it's in parallel. So the total resistance, if it's in parallel, will be 1 over 2 plus 1 over 2, dot, 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 1 over 2. You have 10 of them, so that's 10 over 2, which is 5. So then the OR will be 1 over 5, which is 0.2. So now the power would be 144 over 0.2, right? 720. I hope so.
Yeah.
Yeah?
Yeah.
Cool. Okay, are we happy with that electricity question? Yeah? Kim, it's okay for you? Anda, it's okay for you? Alright. So, this week there's only 3 days. And, you know, it would have been nice if only for 3 days everybody could be in every class. But maybe if we had a week with just 1 day, we could get a successful week.
Should I test them?
Are they all on WhatsApp?
Yeah.
So you can send a group message?
Yeah.
So maybe you should send a group message just to see where the heck is everyone. Siba isn't usually late.
Yeah.
Um,
I'll probably start to the alarm again.
yeah. Chow usually isn't too late. Oh dear. Okay. A6. When you're ready there, on deck.
In a particular type of wave produced.
Oh, sorry. I meant. My English wasn't clear. I meant when you finish the message, we can continue. Have you sent the message?
Sorry.
Yeah.
Yeah.
So you sent the message? Okay. No replies, of course. You're a little too quick, yeah?
Not too fast.
Yeah, too fast for a reply. We'll see if they say anything. So, okay, A6. In a particular type of wave produced by an earthquake, the energy travels horizontally along the surface of the ground. What type of wave is this? It's the one on the ground, so it's on the surface of the ground. So if you picture that's the ground, yeah, very good, it's transverse. Okie dokie. Oh, what's the wavelength? So you have V equals lambda F. So lambda equals V over F, which equals 4,000 over 5. So what the heck is that? 800?
Yeah.
Cool. That's fine. It's a nice, easy wave question, right? Okay, let's have a look now. 7. 7 is really nice. Really nice. 14,6 carbon becomes so many neutrons, not neutrons, nitrogen, plus a beta, plus a gamma. Right, so we know for beta it's minus 1 and 0, which forces this to be 7 and this to be 14. That's nice for 3 marks, isn't it? Yeah. Okay. A8. What is... Okay, so you have the wavelength is 7 times 10 to the minus 14. And we want the speed of the protons. So de Broglie said lambda equals h over mv. So v equals h over lambda m. So v equals whatever Planck's constant is. Let me Google over here. constant. Okay, so that's 6.62 times 10 to the minus 34. The wavelength is given to us, and then we have the mass of electron, which is 9.11 times 10 to the minus 31. So when you're ready, you can give me that. Yeah? Great. Great. Okay. Well, who did we get? We got Matt. What happened to you, Matt?
My bike is in the school.
You forgot your what?
My bike is in the school. Yeah, so you want yesterday.
How come you left your bike in the school?
Not the police, really.
Oh, be strong. Cycle in the rain. That's okay. That's okay. What am I doing? Oh yeah, B. If you halve the speed, what happens to the wavelength? Okay, so guys, if you look here, if you halve the speed, what will happen to the wavelength? So if V becomes a half V, then lambda, what will happen? Yeah, very good, twice. Okay, good. And lastly, part C, what wave-like process will occur if particles, like these photons, meet objects with dimensions similar to the particle's wavelength? So I think that's diffraction. So if you have your proton behaving like a wave and it meets something which is about the same length as its wavelength, then it will diffract. Okay. A9. Two large parallel plates are arranged at a separation of 1 centimetre and 1,000 volts between them. Okay, 1 centimetre and 1,000 volts. What is the electric field strength? Electric field strength is V over D, which is 1,000 over 0.01, which is 10 to the 5 newtons per coulomb. B, what's the force on an electron? So F equals QE. That's the charge of an electron by 10 to the 5. Now what is the electron charge? What is it? 1.602 times 10 to the minus 14 newtons then. C. Show the electric field lines between the parallel plates where the upper plate is at a higher potential. So if this is positive and this is negative, the field will go like this. And it's important that you remember that it curves a little bit at the ends. Oh, great. Only one question left in section A. Good stuff. Yeah.
What does it mean by higher potential?
Yeah, so it's just a fancy pants way of saying put the positive on the top because positive is bigger than negative. Matt, it would be a lot clearer if they just said put the positive plate on the top, but I guess whoever is currently writing the exam feels the need to be fancy with their English and to put in a lot of words, even when it's not good for the student. So I would just say the positive plate above the negative plate. Anyways. A10. What is the charge on the capacitor when it's fully charged? So Q equals CV, and they tell us the C is 47 micro and the V is 9. Okay, so what did you get here then? Or what could we get here, please? 4.4, 4.23?
No,
4.23 times 10 to the coulombs. B, what is the energy? That's good old a half CV squared, which will be 47 over 2 times 10 to the minus 6 times 81. So what's that? Yeah, you got it, Matt? Or Kim, do you have it? Yeah, what's this number?
1.9 and 3 minus.
Yeah, okay. C. What capacitor would you need to store double this amount of energy? Okay, so look, you have E equals a half CV squared, and they want this guy to be double. So what would you have to change about the C? How would the C have to be different if you want the E to be double? Yeah. So I'm very confused why this question is 2 marks. It feels like it should be 1 mark, because the answer should just be double 47, which is what, 94 microfarads?
Yeah.
I'm going to check the answer scheme to make sure I didn't oversimplify. No, that's it. Yeah, that's it. 94 microfarads. Now, something worth pointing out here. If you look, please, at A8B, and also A10C, can anyone see what's in common with those 2 questions? Say again? Yeah. And I think, I can't find it here. I find it. B3, A2. Have a look at that. B3, A2.
B3. No, I was also asking about how.
Yeah. And kind of similar at the end of B4, B3. It's not quite the same, but it's a similar idea. Yeah. So, what I'm trying to do is give you some insight into the person who writes the exam. Try to get inside his head. Okay? So, there's a couple of things I can tell about your exam writer. First thing I can tell, he's heavy on the English, meaning he likes questions where you have to define stuff and you have to explain stuff, things like this. Now, to me, that's a bad thing because, well, maybe not the definitions, because you should know your definitions, but certainly what is a bad thing is he uses quite difficult English sometimes in his writing of the question. So I'm okay with this, to be honest, because you should know your definitions and your explanation, but I don't like when he does this. Second thing I noticed, so when people write exam questions, sometimes they, if the question's supposed to be 20 marks, they don't like imagining 20 marks of questions. They, you know what I mean? Like they run out of imagination and they have to think, oh, what am I going to ask the student now? So you can see from this exam that one way he likes to stretch out the question is to ask you these what if. So, for example, if you had V equals lambda F, they'd say, what would happen to the V if the F is doubled? These what if double kind of half questions. Do you understand what I mean? That's another style of his. Another thing about him,
so it is the same one that's going to write
I think so. Now, I'm not 100% certain. I think so. One other thing I noticed about him is he really, I think, really comes from an electrical engineering background. And the reason I say this is because he sometimes puts questions in the electricity which I think are more complicated than what you need for the IFY. And I'll give you a good example, okay? So, if I go, look here. These exams go back to 2005. So all the way up to 2005 to present, the electricity question, it didn't have this guy in it, in the circuit, or it didn't have the other one, the light dependent resistor. These are two things which have come up in the exam recently, frequently, and I think that's only because he's writing the exam. Whereas in previous years it would just be normally a simple resistor they ask you to draw in a circuit. Okay? So it means you want to be careful before you start the electricity question to make sure you can do it, because he might make it a little bit hard. Okay? This is nice for you because it gives you easy marks then. But this will be a problem if your English is quite weak, which I don't think it is for any of you guys. I think your English is okay. Anything else worth telling you about the exam? So if we just had a quick look at section B, what were the B topics he picked? So B1 he picked was materials. B2 was electricity. B3 was fields. B4 is waves.
Waves.
B4 is waves.
Okay.
And B5, atoms. So, does anyone remember what my rules were for doing the exam? Does anyone remember?
Yeah, fields.
Very good, Matt.
Heat materials.
Don't do fields. Okay, now, the next thing you need to check is which question, if any, asks you to draw a graph. So if I look through this,
The first one.
it's the first one, isn't it? They ask you to draw a graph in part B. Now, how many marks do you get for your graph? That graph question 4, 5, 6, 7, 8, 9, 10, 11 marks, you know? It's quite good. So, for this paper, you would do question 1. So we figured that out. And I said always do the atoms question. So if I look at the atoms question here, you can see it's quite nice. Part A1 is you have to explain how you can keep a constant rate of fission, referencing the control rods and the moderators. So you have to, in other words, the question is explain what control rods and moderators are. The control rods can be raised and lowered to control the rate of fission. So when you put the control rods down, it absorbs the neutrons then. Moderator is a material like boron, I think we said, which absorbs neutrons. Yeah. Part 2 is a simple balance the equation. And you remember the graph in part B? Which side is the fusion side and which side is the fission side on the graph? Oh, Matt, you had a 50-50 chance and you got it backwards.
Fission is the right.
Yeah. And then it finishes off with a half-life question. It's a very good question. It's a very good question. Right, what else did I give you as tips? So we have 2 questions done. And I think I remember saying I like the electricity question.
You have to choose 3 of them.
Yeah. Really your choice comes down to electricity or waves here. So if you look at the wave question, maybe you like that. If you look at the electricity question,
There's so many words in waves.
what's that? Too many words in waves, yeah. What about the electricity one? No, the electricity one looks okay.
There's a little too big.
No. So, I think if you were a student sitting this exam, you would do question 1, 2 and 5 would be your best choice for success. 1, 2 and 5. Yeah. Okay. So what we'll do now, in a few minutes we'll have a look at the coursework, but I want to give you just a few minutes to do, which one do you want to do now first, 1, 2 or 5? Well, you don't really have graph paper, do you? So, do you know what, because we just finished atoms, I think 5 would be a good one to do. Yeah, so if we can all just try 5, and then we can have a look at the coursework there. Do you think Siba and Chow will watch this later, or we leave them a message? Sleepy students. And then there's Siba. And there's Chow. And I need to draw Chow with his umbrella. And Siba, what does Siba always have? She always has her hood up. I could try and draw a hood. No, that doesn't quite work.
Give her a Starbucks.
Yeah, Frappuccino. There now, okay. Right. We'll see if they say anything in the next class. It will prove that they watched it then.